sure your hearts or you guys go, square roots, no big deal. No comment. So, actually, first question. If I say to you, what's the square root of 9? What do you guys tell me? How'd you get that? Because a square root is what number times itself makes 9. Then you're well primed there. Yes, you told me it's 3. Why isn't it negative 3? Because negative 3 times negative 3 is 9. It doesn't. Actually, technically, negative 3 is also an answer, but somewhere in the deep dark past, mathematicians decided that when we were going to do square roots, we were always going to use the positive value, unless indicated with the plus or minus. And so they call that the principal root. So we do always give the positive as an answer, unless it's specifically indicated otherwise. So you won't do negative 3 most of the time, but it actually is a solution to that. Okay, so I'm pretty sure you can handle that. And if I said, name me the perfect squared numbers from like 1 to 12, do you know your perfect square numbers? 4, 9, 4 squared 16, 5 squared 25, 6, yeah, okay. Okay. You really need to be able to see those coming at you, then be familiar with your perfect squares. Okay, yeah, probably, hopefully you know 11 squared, 121, and 12 squared, 144. Okay, you may or may not know past that point. I will point out, it's kind of interesting, 13 squared is 169, and 14 squared, it just reduces that, or reverses it, it's 196, same digits. 15 squared is 225, that's fairly common. So, most of the time, I'm not going to get them that big on you, and I'm certainly going to encourage you to try to always work and keep yours down small, because it's no fun to do these with big numbers. It's just pretty ugly. But my question is, so what do you do with a square root if it's not a perfect square, if it's not 36 or 49?
You put like whatever you guys use how many times on the outside?
Yes. You have to think of two numbers that multiply to make 28. One of them has to be a perfect square. So think of two factors of 28 in which one of them is a squared number. Yeah. We know it's 4 times 7. So therefore, we take the square root of 4 to be 2, and that goes on the outside. Since 7 is not a perfect square, it is not let out of jail, and it has to stay on the inside. You only get out of jail if you're a perfect square. And so then you have 2 times the square root of 7. So if I said, what's the square root of 45, you all would jump on that and say, 9 times 5 would work. And so the square root of 9 would be 3, and the 5 just hangs around inside the root. Okay. What if I said do square root of 72? Okay, most of you said 9 times 8, which would, 9 would come out, and it would be 3 times the square root of 8. Yeah, 8 breaks down again, doesn't it? Now that's exactly the question I'm about to ask. We know that 8's going to be 4 times 2, so when you take the 4 out, it's going to become what? The 4 comes out and becomes a 2. The question is, do I add it or multiply it times the 3? You multiply it. Because technically, it's actually, you're actually saying it's 3 times 2 square root of 2, which gives you 6 square root of 2. So yes, when you take it out, if there's a number out front already, you just multiply them together. Now, what would actually been the easier way to do that? There's a bigger perfect square number that would have gone into 72. Not 16. Yeah, 36 times 2. So if you can find the biggest possible squared number, it makes your life easier, because it would have been faster in this case to go, oh yeah, 36 times 2, that's really just 6 times the square root of 2. We got the same answer in the end, we just had to go to more work. But sometimes you might have really bigger numbers that you don't know what goes in there, so break down the smaller ones and you'll eventually get there, if it takes you more than one breakdown to do it. Okay. So that's breaking down roots. Now, can you add them? This is extremely difficult. If I gave you 2 times the square root of 3, plus 8 times the square root of 3, minus 4 times the square root of 2, can you add all that together? I can add all 3 together?
You can add the first two.
Yes. Good. You remember, yes. They have to have like roots. So you have to have the same number in the square root before you can add them. So we can add the first 2 since they're square root of 3s. We cannot add the last one on. When you add them, what do you get? Yeah, you'd add the outside number, so you'd get 10. And that's the question, is it 10 square root of 3 or 10 square root of 6? Yeah. Yeah, because you're saying I have 2 square roots of 3 plus 8 more square roots of 3 would give me a total of 10 square roots of 3. So, yes, you don't ever change that number on the inside. And then the minus 4 square root of 2 is different, so it just sort of has to hang around for the ride. We can't do anything more with it. Now, last block, they assured me that if I just type this in my calculator, it would do it. If you type that in your calculator, what will it give you? Well, it'll do it. It'll give you the decimal values of it all. It won't add roots to root and give you an answer as a root. It just turns it all to a decimal and throws the decimal back at you. Now, the calculators my calc students have, those will actually add the roots and keep them as roots and simplify it if you want to. But they only get to use those things on a limited basis. All right. What if I was to give you the square root of 24 plus the square root of 54? Those aren't the same, so I shouldn't be able to add them. Yeah. But you do have to ask yourself, can I break them down? Because if I could break them down, then maybe I could add them. So what would break down 24? 4 and 6. So that would become, square root of 4 would be 2, and so I have 2 square root of 6 there, plus, okay, what breaks 54? Yeah. 9 times 6, so the 9 would come out, and I would have 3 square root of 6. So now something that looked like it was impossible to add, turns out that they actually have like roots, and I'm gonna get 5 square root of 6. So always ask yourself, can I reduce that root? Because sometimes when you reduce it, then you can do more with it. Have I blown your mind so far? Okay. So you're staring at me. There's lots of yawning going on. And if you start yawning, you're going to make me yawn. So y'all have to be totally energized and enthused here. It's Tuesday. You have a volleyball match.
An hour away, but you have to do your homework on Friday.
Okay. Are they competition or not? No. Oh, okay. Okay. So I understand. You wouldn't mind driving an hour so much if it was a competitive game. I didn't need that in yellow, but oh well. Multiplication. Here we go. We can add and subtract now. Woo! I want to multiply this time. So now here comes the question. I couldn't add two roots unless they had the exact same number inside. Can I multiply two roots? Can you take square root of 2 times square root of 6? Because you can't break those down. And the answer is yes. You're allowed to multiply roots. So that is really square root of 12. Now, a lot of times then once you multiply, there's a very good chance it will break down. What breaks 12? 4 times 3, so that would give me 2 times the square root of 3. So yes, multiplication is legal. So what if I want to take 3 times the square root of 6 times 5 times the square root of 3? That's the question. Do I take the outer numbers times each other and the inner numbers? Or do I have to distribute the 3 times both parts? What's your gut instinct? Yeah. Outside numbers multiply inside numbers. So outside numbers are going to be 15. Inside numbers are going to be square root of 18. Are you done? Is that simple? 18 would break down as 9 times 2. And so if I take the 9 out, I'll really have 3 times the 15 out front. And 3 times 15 would be 45 square root of 2. Y'all seem like you know this. That's good. That's excellent. You should have seen some square roots in geometry because you at least, I know you have to do the special right triangles with the 1, 2 square root of 3 and the 1, 1 square root of 2 stuff. By the way, those special triangles are big on the ACT. They always bug you about those. I will eventually come back to them, but not till May. All right. Here is a decision thing. Square root of 24 times square root of 72. I can multiply that. But if I multiply that together, that's going to be a pretty good sized number. And then I would have to sit there and figure out what numbers break down this very big number. It would be a pain. So yeah, I recommend if you're multiplying, break them down first, then multiply them. It'll cause you a lot less headache in the end. So what breaks 24? 4 and 6. So that would become 2 times square root of 6. 72 we just did. What was the good number to break 72? 36 and 2. So that will give us 6 times the square root of 2. Oh, that's funky. 2 square root of 6 times 6 square root of 2. Which means I'm going to get what when I multiply? 12 times the square root of 12. Oh, that's a cool answer. I should just leave it that way. You want to leave it that way. Well, unfortunately, we need to break it down. And 12 breaks down with 4 times 3. So if I take the 4 out, it'll become 2 times the 12 that's already there, and I'll get 24 square root of 3. And there is a lovely simplified and reduced answer. So definitely don't multiply and get big numbers. It's horrible. Break it down first. Okay. Finally, y'all, this is too easy. We each have to challenge your brains a little bit. Where's your sense of adventure, Nick? Because your brain's over there chanting, bring it on. I have 2 different quantities there. Any instinct as to what you do to multiply that? I got a factor, a FOIL, which I think is what you mean by factor.
What about if you did, multiply them together and then like 3 plus 4 times 7, or 7 plus 5 minus 2.
Are you allowed to combine them when this one doesn't have a root on it? They have to be like roots, and so 3 is not a root at all. You cannot combine them, and so, yes, those of you who said FOIL would be correct. Woo, doggies, yeah. It comes back. Okay, do we remember what the FOIL stands for? Okay, and when it says first, what are the first? Yeah, the first one in each parenthesis. So what are the outers? The front and the back, the outsides of this. The inners are the two in the middle, and then the last are the last in each parenthesis. Okay. You're going to, from here on out, for the rest of the year, you're foiling like all the time. So if you don't like to foil, you might as well get used to it because you're going to do it a whole bunch. So if foiling is going to become one of those automatic things you don't even think about, you just do it. So yes, you get to foil this thing. So what do I get when I do first? 15. Outers?
6 and
Positive or negative? So negative 6 squared to 5. Okay, inners will be, and then last, this is the one to be careful of. Outer times, I shouldn't say outer, but these numbers in front, 4 times negative 2 is going to be negative 8. Well, what's square root of 5 times square root of 5? Yeah, okay. So yes, I'm going to write it out once we have longhand. That's 25, but we know 25 is really just 5, so you really have just 8 times 5, or that's minus 40 there. Yeah, so we're really looking at minus 40. So now if I actually combine that, I got 15 minus 6 squared root of 5 plus 20 squared root of 5. Are there any like terms I can add together and make this a little better? Yeah. 15 minus 40 would be normal, regular numbers, so I can make that negative 25. And then inside negative 6 squared root of 5 plus 20 square root of 5 would be 14 square root of 5. And ta-da! You have foiled it together. You did not die from that. I don't even think you were in pain from that. Key thing is just be careful. Stuff on that, watch the little mistakes. That's where we have issues. So, we're ready for the fun now. We've added, we subtracted, we multiplied. What's left? Division. What time am I on? Oh gosh, you guys are supposed to yell at me.